Hey guys, today's video is going to be on the frozen evaporator coil in air conditioning systems and the causes of why it freezes. And before we get started, there's a couple key concepts to understand. So, concept number one, for every refrigerant, there's a unique pressure and temperature relationship. Our example being R22. At 69 psi, it will have a temperature of 40 degrees Fahrenheit. And for any increase or decrease in temperature or pressure, we can reference a PT chart or pressure temperature chart, and we can see a whole row for every pressure and every temperature what the other value would be. So if we had 45 degrees, we could see the corresponding pressure for that temperature and vice versa. So moving on to concept number two, temperature and pressure are directly related to each other. So if pressure goes up, then temperature goes up. And if pressure goes down, then temperature must go down. And we could say it backwards as well. If temperature goes up, then pressure goes up. And if temperature goes down, then pressure must go down. So now that we've seen these two concepts and understand them, we can move on to the flow chart and the reasons behind why the coil freezes. So the way I think about it is reduced flow is why it freezes. And there can be two causes or two different categories of reduced flow. We're going to start with reduced airflow, and this could be caused by the blower motor running too slow or not running at all, or dirty air filter or a dirty evaporator coil from a missing or improperly placed filter. So, and how this can freeze the coil is that normally when your blower or your filter are clean and your evaporator coil is clean and air is flowing across it, we're moving a certain amount of heat into that coil. And because we're moving heat into the coil, we're adding temperature to the coil. And because temperature goes up, then our pressure must go up. So we're keeping our evaporator coil at a certain pressure because we're moving heat into it. And because of that, we're maintaining our goal of 40 degrees Fahrenheit in the evaporator coil. So that's column number one out of two of reduced flow. The other side of the column is reduced refrigerant flow. Moving down, causes of this is further divided into two categories: restricted metering device and a leak or low refrigerant charge. So with this category here, with these two items, it's also important to know that the compressor is a positive displacement pump, and it's trying to pump a constant volume of refrigerant. So anytime we have a restriction in our metering device and it's not letting the proper amount of refrigerant into the coil, the compressor is going to start reducing the pressure in the coil. And because the pressure is being reduced, decrease in pressure, decrease in temperature. And if it's severe enough, we're going to drop below our 40 degrees Fahrenheit and work well down towards freezing of 32. And if we go below 32, of course, we risk freezing up the coil. So, low refrigerant charge or a leak in the system. And the other category, a restricted metering device, is also not going to feed the evaporator properly, and we'll end up with a low pressure condition as it's being starved of refrigerant. So in this category of metering devices, we have thermal expansion valves or TXVs, a piston or capillary tube. So causes of each: debris or moisture in the metering device. Of course, if we have debris, we have a blockage. And in capillary tube systems, maybe more sensitive than most, if we have a lot of moisture, enough to actually freeze it will cause a restriction which will come and go. And going the other way is a faulty TXV. If it has failed in the closed position, it's also going to starve the evaporator or not feed enough refrigerant into the evaporator coil, therefore reducing the pressure and the temperature to 32 degrees or less, causing our problem of the frozen evaporator coil. So going through it quickly one more time, reduced flow rate is how I think about it. That could be reduced refrigerant flow or reduced airflow. Again, we're always trying to put a good heat load on the evaporator. Because we're moving heat into the evaporator, it's going to maintain our pressure and therefore our temperature in the evaporator coil, that goal of 40 degrees Fahrenheit. So we want to look to our blower motor running at the proper speed and running in the first place at all. And again, the air filter must be clean and the evaporator coil also must be clean and not filled up with any other debris that would reduce the transfer of heat into the evaporator coil. And down the other path of reduced refrigerant flow, a leak or low refrigerant charge. Again, the compressor, that's a positive displacement pump. If the evaporator is not being fed properly by the metering device, because it has a low charge, the pressure is going to fall and the temperature will fall. And again, same here with restricted metering device. 3 different basic types: thermal expansion valve, piston, and capillary tube. And pretty much the blockage or the actual failed thermal expansion valve failing in the closed position. So if this is it, your subcooling will be higher than normal and you'll have a very high superheat because the coil is being starved of refrigerant. So there's not a lot of latent heat going on and you'll get a lot more sensible heat. So hopefully this helps everybody out. Thanks, guys.